Good afternoon, all. Welcome to the seventh episode of Earth and Planetary Science seminar series organized by IIREES, Institute for Innovation and Research. And today we are glad to have with us Dr. Sandip.K.Roy to deliver the seventh episode of EPS3, I would rather say. So far as IIREES, we have organized several lectures starting from the subject of geochemistry up to earthquake geology and ranging from planetary science, astrobiology, and also machine learning. So today it's a great opportunity to for us to have Dr. Sandip Rai to organize a 2 days workshop on petroleum geosciences. So to introduce him, I would like to invite Dr. Ranjan Sharkar, postdoctoral fellow of Max Planck Institute of Solar System Research, Germany. Ranjanda, stage is yours.
Thanks, Om. Thanks. And hello, everyone. And thanks to you, for all of you, for joining us today for the seventh talk in the Earth and Planetary Science Seminar Series. We are very happy that we have with us today Dr. Sandip.K.Roy, who is going to give us a very interesting talk titled The Philosophy of Petroleum Exploration, Nebulous or Clear. And he also has a very wonderfully simple storytelling way of explaining things, and as we'll soon find out that. So Dr. Sandip.K.Roy, he's an experienced exploration geologist in the oil and gas industry with wide exposure to Indian and international sedimentary basins. Dr. Roy is also a recognized industrial professional on the geology of the Andaman Basin in India, and he has written several papers on tectonism and sedimentation related to the basin. He has also made presentations at various international conferences, and he is a member of the AAPG, SPE, IAS, GSM, and the GSI. he has been with the Oil and the Natural Gas Corporation of India Limited for 21 years, and he's also had several stints in the BG Group, UK, the Petra Energia, Brazil, Petronas, Malaysia, and the Directorate General of Hydrocarbons from the Ministry of Petroleum and Natural Gas, the Government of India. He holds a PhD degree on process sedimentology of the Andaman Fish from the Indian Institute of Technology, Bombay. So, Dr. Roy would be discussing with us today some very relevant and practical insights into petroleum and its exploration. The philosophy behind hydrocarbons search, it appears to be nebulous at first thought, but whether it is really true, that's what we are going to hear from him. So he'll also be discuss things like, are there definite paths towards it with the fuzzy logic, the uncertainty risk, and vice versa. He'll also examine different aspects of exploration philosophy, namely the approach, the creative process, the stages, and many other factors that would bring out a perspective on that issue. So let's not wait much. But before we begin, may I please remind you that keep your microphones muted during the entire talk, and you can post your comments and questions. And Dr. Roy would love to answer those. But please post them in the chat box, and we will at the end of the talk we'll surely pick up on those. So let's hear it from Dr. Roy himself. Dr. Roy, please take over.
Well, thank you very much. And it's wonderful to have you here. There are some known faces I'm finding here and a lot of new interesting friends I'm making out here. And I hope I'm fairly audible if one of you replies back that I'm clear. Okay, great. So friends, can you see the screen?
Perfectly fine, sir. Please
okay. See, initially the talk was entitled Philosophy of Petroleum Exploration. I've just added two words towards the philosophy of petroleum exploration here, whether it's nebulous or clear. Now here we can see that these are my own diagrams here. I mean, I've just made some kind of hills and river, some kind of a braided channel system coming in. And here the geologist, he's looking at it, looking at the rocks with his hand lens. And then he's thinking about sequence stratigraphy, drawing the sequence boundaries and drawing the maximum flooding surfaces, all happening in his mind by looking at the field. So the outcrops are very, very important. Now we delve into this aspect of the subject straight away. I have presented this picture. It's slightly shocking, but I just want your minds to be oriented towards something different. Because all these slides that I'll be presenting is something which you will normally not expect. There'll be geology, but there'll be a bit of management and there'll be a lot of thinking here. So I want you to be oriented differently. That is why I've posted this. So I drew these two faces, which looks very, very alien. They look like somewhere from Mars or some extraterrestrial planet from some other galaxy. Particularly the guy on the right, he has got three eyes. Both the guys has three eyes. The guy on the left has a beard, something like me. But if you look at the box carefully, you'll find that there is geology in this, because on the left you can see a horse block and two grabens on the side. All right, and on the right, it's a convergent margin situation where a plate boundary, where a plate is going down. And then you have an accretionary prism here, series of thrust packets out here, series of thrust packets. And then you have a four-arc basin. And then you have a volcanic arc throwing gases and volcanic products on either side. And then you have a back arc with a spreading center. So I do a bit of drawing. So when I do drawing on my own, a little bit of geology creeps in. This is just to orient your mind so that this presentation is going to be different, and it's not going to be traditional textbook kind of thing that you're going to hear over the next 20 minutes. Now, etymologically, when you talk about philosophy, it is a way of thinking of certain subjects like ethics, thought, existence, time, meaning, and value. And it involves responsiveness, reflection, reason, and evaluation. In essence, it means that you go deep into any subject, whether it's physics, chemistry, or even oil exploration for that matter that we are discussing. It means to go deep into any subjects and then understand the aspects behind it. And that's exactly what is philosophy. This sounds very nebulous. Of course, it is nebulous, but there are certain things which are actually very, very organized and straitjacketed. We'll find out soon. Now, the part of the talk, we'll be talking something on the approach to hydrocarbon finding, the creative process, the stages of petroleum exploration, the characteristics of oil finders, idealized exploration teams, which is very, very utopian actually, and then management decisions to prospect predictions. So these are some 5-6 aspects which happens in when you talk about the philosophy. And I wanted to specifically talk about these. They form some aspect. They don't cover every aspect, but they cover some aspect where it will hold some interest to you. Now, initially 3-4 slides on exploration, very simply, keep rudimentary and keep it very simple. For oil and gas, you require a source rock, which is a fine-grained sedimentary rock which contains organic matter. And over millions of years, that organic matter is converted into liquid or gaseous hydrocarbons. So from the source rock, the oil or gas migrates to reservoir rock. And here we have kept, thin section positions here of a sandstone on the left and a carbonate on the right. And here within these blue pore spaces, this is where the hydrocarbons occupy themselves. And then you have got a trap. You need some kind of a anticline or a stratigraphic trap or some kind of a fault trap. So you need a trap where the oil migrates upwards and houses itself. And obviously there should be a seal, like a tight impervious rock, like a seal rock, like a shale, or a tight carbonate, which doesn't allow the hydrocarbon to go away. Now, this is very, very simple. You must be wondering why S.K.Roy is talking this. Very simply, whatever research you're doing with respect to oil and gas, you are actually trying to address these 4 elements. You're trying to address the presence of these elements, and you're trying to explain the effectiveness of these elements. So the presence and effectiveness of the reservoir, trap, seal, and source is what everybody's trying. There are sophisticated methods. People have gone into sophisticated stuff like rock physics. They have gone into inversion, seismic inversion. They are going to so many other things. They are going to sequence stratigraphy. But all these endeavors, all these sophisticated endeavors are ultimately trying to explain some aspects of these 4 elements. Now, approach to petroleum exploration, it should always be from regional to local and never be from local to regional. So it should come from the plate tectonic scale to the sedimentary basin, understand the basin, then come to the petroleum system, then come to the hydrocarbon play, and then to the prospect. What has happened over the years is because of the mechanization, because of the software going very, very good, the electronics industry doing so well, and you have got so sophisticated softwares. They are very, very important. They are required. But unfortunate part is people are bogged down on their workstation, and they have forgotten to think about the play. They have forgotten to think about the petroleum system. They have forgotten to think about what kind of sedimentary basin it is. And that is why the discoveries are not happening. So for discoveries, you must have a broader picture in your mind of the kind of sedimentary basin you have, the kind of sequences you have in the sedimentary basin, the mega sequences which are defined by unconformities or correlatable conformities. And then you must understand the petroleum system in them. That is the source rock generated, the power of the source rock, to how much reach these source rocks have got in the basin, up to where it can generate and reach their hydrocarbons. And then a hydrocarbon play, which is essentially a reservoir game where similar type of genetic features are all clubbed together. It's like a herd of sheep, moving around in one direction. They are genetically, they are very similar. So in the subsurface, within a sequence, in certain part of the sequence, if you find series of anticlines of similar genetic nature, or if you find stratigraphic traps of similar genetic nature, we call them a play. As simple as that. And from within that play, you go and finally target one prospect, drill them, find oil and gas, and then start targeting the others. So the mantra here is always think on a bigger picture and then come down to your prospect level. Now, this is a map of a play. This looks like a sausage or something like that, but actually the four elements I talked about, the source, reservoir, trap, and seal, the presence of each element and the effectiveness of each element. You prepare maps for each of these different sequences. A sedimentary basin comprises of 4 or 5 mega sequences, and the mega sequences can be broken down further into sequences. Now, whether it's a mega sequence or a sequence, you are going to prepare maps for the prospective sequence or the mega sequence in terms of the reservoir, source, seal, and charge presence and their effectiveness, and then superimpose them one above the other, either on ArcGIS or on your tracing paper, and then find out that which is the sweet spot or the area which has all the good qualities for producing hydrocarbons. This is exactly what you call as a hydrocarbon play. And play fairway analysis is something which is actually gaining ground with the top petroleum companies. But not all companies are practicing this with utter seriousness. So it is a time now to prepare to do the play fairway analysis. You prepare the gross depositional environment maps or the GDE maps. And for each of these elements like source, reservoir, trap, and seal, you prepare their presence and effectiveness maps, superimpose them, and then you get the play fairway for each of the sequences. So this is important, looks apparently simple, but people are not following this in true sense. But this is something which is emerging. Now, what does it take to find petroleum? Is it technology only? Or is it science? Or the third element, which normally people would not expect, it is creativity. Science, creativity, and technology are three ends of the triad here. And what has happened is, because of the advancement of technology, which is essentially required, but technology has overtaken the science. The thought process is important. The human mind is supreme. So the thinking has to be very, very important. The science is very, very important. And along with the thinking, there has to be a lot of nebulous thinking, which is called as creativity. All the geoscientists, whether you are in petroleum exploration or you are in mineral exploration or you are into some kind of research, whether with hard rocks or soft rocks, it is very, very important that you keep your creative instincts open. Apply the principles of geology, but you should always question certain principles, existing principles, and that is how the subject advances. So fundamentals of the subject should be very, very strong. The applied aspect should be there. The rudiments of technology should be there. But along with it, what is required is complete out-of-the-box thinking. So all geologists should be very, very creative, and they should have out-of-the-box thinking, whether you want to discover oil and gas, or whether you want to discover any land minerals, or whether you want to advance yourself in your research. And that is how we advance. Now, Roger Sperry, there was a guy who was doing brain hemisphere research some 40 years back, and he found out that the left and the right hemispheres of the brain, they function differently. We know that the brain comprises of neurons and dendrites, the long chains like dendrites, and there are synaptic buttons. Through the neurons, these thinking chains, they go from one neuron to another neuron, and they're all connected. And the brain is something like a branch of a tree, moving like a branch of a tree. Now here, interestingly, Roger Sperry found something very interesting. He found that the left hemisphere of the brain, it sees the logical aspect of things. We are all trained to be very logical, sequential, logical, language, mathematics. These are all very, very logical and organized. And that is how the society trains us. But at the same time, the right side of the brain is dreams, color, fuzzy logic, spatial, music, images, all these things which are very, very nebulous happen on the right side of the brain, and they lead to divergent thinking. On the left side, it leads to convergent thinking. Now, if you watch any geologist, you'll find that the right side of the brain is swollen. I was only joking. I mean, because they have to be creative. They have to apply the processes very creatively in order to take the science ahead. So this is exactly what we're going to see in the next slide. Now, creative process in petroleum exploration. This is very, very important, the left brain and the right brain thinking. For a balanced thinking, you require to use your right brain sometimes, and sometimes you need to require to use your left brain sometimes. Now, but the creative aspect of it, any idea or project, when you start a project, it is the right brain which starts the project, which starts the idea. This is what we call as the first insight. On the right top box, it is the birth of an idea. It is only then you realize, okay, this is a problem. Now let me solve the problem. So this thinking is a creative thought which comes from the right side of the brain. And the moment you get this thought and you start, or if you are given a project to do, a scientific project to work or a scientific research to work, from the right first insight, you go to the left brain and there is a preparation stage. You gather your data. You gather and assess your data. And then you weigh the options, which data is doing what. Then you start drawing maps. Then you start drawing your curves, start drawing graphs, do your experiments. And everything, it's a left brain functions. After you have done these mapping and your laboratory research or field work and your remote sensing or whatever, you find that you have the product ready, but you are not immediately able to understand what it means. You draw a lovely contour map, but you're trying to gauge what does this contour map mean. You don't straight away get into the thought of what it exactly means. This is what we call as the struggle stage. You're struggling. You've prepared the work. You're prepared, but you're not getting the crux thinking of how you should go ahead. You're not able to interpret it properly. Now, when you come to this struggle stage, immediately your thinking shifts to the right, and there is an incubation stage. There is a stage when you're not productive, actually in office or in your laboratory. You're not productive because you're not getting the answer, but your subconscious mind is actually working towards it. So when you're outside your office, when you're outside your laboratory, in doing something else, when you're watching a movie, or you're just about to go into sleep, or just about to wake up from sleep, or in your dreams, suddenly you get the answer. Suddenly it appears to you, oh, this is the answer for this problem. This is how you should do it. And this is known as the illumination stage or the breakthrough stage. Friends, can you hear me properly?
Very well, sir.
Okay. So this breakthrough stage...
Right, so we can hear you.
It's okay? The breakthrough stage or the illumination stage, this is the most important stage or the creative process that happens from the right side of the brain. If this doesn't happen, then that work actually remains stagnant. And this happens with many projects. Out of 10 projects we do in the industry, 10 interpretation projects we do, or 10 work we do, hardly 1 or 2 actually fits the bill. They push ahead because they have got a breakthrough thought in it. When there is no breakthrough thought, then you're stuck at the struggle stage and the incubation stage. Then you come to a verification, mechanically make the report, and then you submit it to the management. They are happy because you've done your job, lovely maps, beautiful color, excellent Zani sheets from your softwares. The report is there, but the scientific thought is not there. This is what is important. That is why creativity is so important in petroleum exploration. The illumination has to happen. And this happens when you are conscious about it, but you're in a kind of constructive strain in terms of time, that in a certain time you'll have to do it, not too much constraint and not too much loose. If you're casual, if you're having a lot of time, okay, you give it after 1 year, then you lose interest and the illumination never happens. Or if you are given too short a time to complete a work, then also illumination does not happen. But if you are given certain time where you are constructively constrained of a little bit of time and you have to finish, it is where you are actually conscious about it and you get the illumination. And this is the breakthrough stage, and this is the creativity that happens. And if the creativity has happened, you verify your thought against the data, which is known as the verification stage, and then you polish the report and publish it, and then you celebrate with your bubbly. Then you have your drink or whatever, or good food or anything, and you celebrate. And this guy had his illumination when he was about to go to sleep. I did this drawing some 10, 15 years back. I put it back again. Now, stages of petroleum exploration. You will not find this in any book or in any journal. In 2006, I tried to write a paper in SPE, and this is how it goes, that the formative stage, when you are coming to a sedimentary basin and you know nothing about it, it's a virgin basin, first thing you do is you do geological mapping. All right, you see what are the rocks exposed on the surface. Are they source rocks? Are they good reservoir rocks? What kind of stuff is there? And then you look at the surface oil and gas shows. You do a geological reconnaissance. You do remote sensing, field mapping, and then you may drill a parametric well just to decipher the stratigraphy. What is there in the subsurface? You're seeing the rocks from your mapping on the surface, but what is there in the subsurface? Petroleum exploration is one field, in geology, where actually the scientists are probing very deep into the recesses of the Earth's crust, 3 kilometers, 5 kilometers, 6, 7 kilometers. No other branches even are going this deep. And that is why, because when you go deeper, the pressure is more, the temperature is more. So it becomes more and more difficult to drill in deeper depths of 5,000 or 6,000 meters. That is why complex engineering comes into play. Land minerals, whether you take coal, copper, gold, all you get them on the surface or very close to the surface. You drill a bit, 100 meters, 200 meters, maximum 300 meters, or at best 400. Even coal, if you want to take them out, the underground mapping happens at 400 meters, maximum 600 meters. There is a rare coal mine which may be up to 1,000 meters, which is there in eastern part of India. We have one. But oil exploration is such, you go very, very deep into a sedimentary basin, and then you get the information from there. Okay, now from this knowledge building stage, you have gathered data, and then you go for 2D seismic surveys. For gravity magnetic surveys, the gravity magnetic surveys gives you the basin configuration, and from the basin configuration, you plan your 2D seismic surveys. And if 3D seismic survey is cheap, you can do that as well. You do some surface source rock studies, geochemical studies, and then you do exploratory drilling. Now, this is the data idea generation stage where exploration concepts are built up from initial exploration. And I call it as the stepping stone stage. So you probe through drilling and you make a quick discovery, and then suddenly you understand, okay, there is some oil and gas show here, and we have made a discovery. So there is a chance. How do we spread out? How do we spread it and do our mapping out the discovery and things like that? Then you plan intensive exploration. You come to intensive exploration stage where you do further 2D seismic, you do further 3D seismic for specific place that you've identified. And then you, with a lot of exploratory drilling, huge amount of data generation has happened, and there is an explosion of data, and you are really struggling how to manage this data. And this is where your softwares and your computer comes in. This is where it helps actually. And you come up with alternate models. If something is not working out, you come up with some other thought process, alternate models, and you do try out something different, or you drill somewhere else, and then you do your intensive exploration. And after you have established the oil and gas pool on oil and gas area, you keep on drilling, and you keep on churning oil and gas from the same kind of lay. There is a human tendency, to be in a state of complacency. And in that complacency, you keep on doing the same things. I've got a structural trap and an anticline from the Cretaceous in the northeastern part of the basin. So I'll keep on plugging that. So every structural trap in the northeastern part of the basin, I keep on plugging the Cretaceous. In some I get oil and gas, some I don't get oil and gas, but I keep on plugging it. I'm not ready to change. This sense of complacency is actually the biggest enemy. The moment you see that you have identified a play, you are getting oil and gas, but it is not being very fruitful. You're getting a lot of dry holes after that. It is the time to change. It is the time to chase something else. It is the time to think completely different. So there has to be a rejuvenation in your thought process, right? In geomorphology, we have read youth, maturity, and old age rejuvenation. In the same place, in same way, in exploration, it happens that you reach a plateau of thought process in with a particular play, and it's the time you have to change. And how do you do that? How you get it very easily? Your discoveries or your production in terms of million tons against the time or against the number of wells drills gives you a curve. This is known as the creaming curve. So from the creaming curve, when your discovery is happening and you're keeping on plugging a lot of hydrocarbons from the same play, the curve goes up and up and up and up. And then when you are not discovering anymore, but you're keeping on plugging with the same play, then this curve becomes flat. And that is the time when you have to chase a different play. That is the time when you have to change your thought process. And that is the time when all your creativity has to come into play and look into something different. Now, characteristics of oil finders, first is there are two key qualities which Beaumont and all have identified to familiarize ourselves with the successful approaches and techniques of other oil and gas finders. How did other oil and gas finders be successful? What do they do? How do they approach the work? What is their technique? And to develop visual thinking skills. Geology, geoscience, geophysics, it's a visual science. So a lot of imagination and visual skills has to happen. Along with that, I'm not saying that the mathematical and logical skills has to go into the back burner, but at the same time, you should be very open to dreaming, open to fuzzy logic, open to different kinds of thoughts and visual thinking. For academic training, you require preferably a master's degree, and you must have improved visual imaging, visual thinking, and imagination. The more you imagine, more better it is, because you come up with more concepts, you come up with more models, and you take up the model which actually is closest to your data, and that becomes your working model. Then you work towards it, and if it fits, it is fine. If it doesn't fit, then you look for another model or another thinking. One more characteristic of oil finders, which I didn't find anywhere written, that they are very, very optimistic, they are extremely bold, and they are risk takers. They are inveterate gamblers. And these explorationists, when everybody has cried out, no, this is a bad area, there's nothing left, let us abandon and go somewhere else, let us look for a new play. But the geoscientist, who's an explorationist, is still at it. He's still looking at if anything is left. Have we missed anything? He's still not letting it go. He's like a doctor who's saving a dying patient. He will still fight it out. And that is the kind of attitude which makes a true explorationist. They should be very, very bold. They should be optimistic all the time, even when others are pessimistic. And they should be risk takers, very good risk takers. Now, exploration teams and team composition. Why we don't find oil and gas? Fundamentally because the nature of the people who are making up that exploration team. We have multidisciplinary team now with geologists, geophysicists, reservoir engineer, and we have a geochemist, and so many of them, which is fine. You require multidisciplinary team now. But the hydrocarbons are not getting discovered because the type of character of the person making up the team composition, if they are similar in nature, then no breakthrough thinking happens. Because they're all similar. They've got all similar thinking in the thought process. You have to be different. You have to need different kind of people making up a team. It should be a conglomerate. It should be some kind of an agglomerate where different kind of people make up the team. It takes all sorts of people to make up this world. You need an intelligent guy. You need average guy. You need somebody who does work diligently. All sorts of people you require. So this was actually identified, through a creativity book called A Kick in the Seat of the Pants by Roger von Oesch, long back. And he wrote another book, which is called A Whack on the Side of the Head. And I love reading these kind of books for whatever reason. And I found out that he had written a very good book where he has talked about the creativity of teams. And I've applied it to oil and exploration, where he talks about 4 roles: explorer, artist, judge, and warrior. The fifth, known as the finisher, I have added Mahendra Singh Dhoni's photograph of how he finishes the T20 matches by scoring runs and taking his team to victory. This is my own addition, but these 4 are by Roger von Oesch. Let us see what they mean. Explorer means somebody who has to come up with a new fresh idea, the guy who brings the fresh idea which becomes the basis of the work. And the artist, what he does, he mixes two different ideas and makes it into a third idea. So he's also very creative. This guy is very creative. This guy is a starter. He actually brings in the fresh idea. And this guy mixes several ideas to make a third idea. And then you have the critic, the judge. And all of us are very, very critical. This is bad, that is bad. It is very easy to find a critic, And they actually are important because whenever you're doing a project or something, and the project is not going in the correct direction, to provide the mid-course corrections, the judge is required. He should be impartial, but at the same time, he should say the good points as well as the critical things about how the project is shaping up. So after the judge comes the warrior. Warrior is the action guy, because in office, most of the people, or even in projects, you'll find most of the people are warriors. What they do? They come to office in the morning and they say, okay, boss, what will I have to do for today? So they are ready for action, they are action people. You require them because they'll actually do the work. They'll actually do the main work. But the thinking has been done by the artist and explorer here. The judge has critiqued it. And the warrior, he does the actual work. And then finally, when thinking the warrior's work, the judge, the artist, explorer, all this is combined to make the final product and push it across to the management. It is a finisher. You need somebody to finish it. The explorer may be a very poor finisher. A finisher may be a poor artist, But you require all these 5 kinds of guys to make up a project. And when you have a team composition as diverse as this, success is there. As I said, it takes all sorts of people to make up this world. So the same thing, I put it here in words. The explorer is the creative thinker. He looks into data, facts, and concepts, ideas of the beaten path, expect the unexpected, recognize patterns. We are all looking for patterns. The artist changes the patterns, different ways of experimenting. He joins concepts, uncanny way of joining two unrelated planes of thought into a new concept. From different branches of science, they will bring it to geoscience here. They reverse some idea, they adapt, they compare, incubate, they ask questions, bring in metaphors. That is the artist. And the judge, he evaluates the idea, looks at the possibilities, the positives, negatives, downside, assumptions, blind spots, bias, and verdict. Because he gives a clear thing of how things are progressing. And then the warrior carries the idea into action, gets going, persistence with the word. He keeps on working, finishes the whole report. And finally, victory, defeat, finally who completes it and gives it to the management is the finisher. And they sell the work. And after selling the work, whether it's a success or a failure, they pause, reflect, and then they move on. This is how exactly a team composition is required. Now, in terms of decision matrix of management to prospect predictions, here I just made a quiet matrix of a management decision, whether they want to explore or whether they want to ignore a prospect, and whether that prospect is actually hydrocarbon bearing. And the top column, in the top, these two blocks, we are thinking of an imaginary prospect, which is very costly to drill. But if you find oil and gas, it's going to be a big gain. And in the bottom, we have cheaper targets here, and it's going to be a small gain. So, and this is the state of nature, and this is the management decision. And what does the management do? Suppose if it's a huge structure, and it's full of oil and gas, and the management decides to drill it, and it's a success case, then the nature of the company changes completely. It is an ideal situation where the correct decision has been taken, a big stuff has been found, and the company really thrives and does well. But if it is there, but the management takes a decision not to drill it, then it is a grave error of judgment. In some cases, it could mean something else as well. Now, if it's a small target and the management has, say, X amount of money, they can drill several small prospects. It depends on how much failure they can tolerate to drill something that they found a small kind of target which is full of oil and gas. And it could be some kind of an error if it is false. Sorry, I'm telling wrong. Suppose if the prospect is not having any oil and gas, it's a false. It's a false target, but the management thinks of exploring it. It's an error. Now we have a success ratio of 3:10, 2:10 or 1:10. That is why most of the decisions happening are actually in this quadrant. Management thinks there is oil and gas. They go and drill it, and there is no oil and gas, or it is so little that it is uneconomic. And sometimes, if the target is not there at all, it's a false target, and the management stops from drilling that, it's a good judgment. This is just one scenario. There can be 20 other scenarios like this. And in fact, for technical decision making, it is the nature of the data on the left bottom corner, the quantum of the data, the confidence in interpretation, the techno-economics, the uncertainty, and the risk appetite. These matter. But actually, before drilling a prospect, there are so many issues. There are economic, financial issues. There are geopolitical issues. There are your environmental issues. All these things, they come together before a management takes a decision. That is why it is a very, very difficult decision, and it is very, very nebulous. Now, while analyzing oil and gas, whether we got a successful target or a failure target, people tell you, to the geoscientists, the bosses say, go and do dry well analysis and find out why did we go dry? Why did we find oil? Yes, pardon? Why did we not find oil? On the reverse side, I am asking you to analyze why my oil was wet. Why did you find oil? What were the conditions of source, reservoir, trap, and seal ideal that made you find oil there? That question you need to answer. How did I get my success? That is important. And how many successes have happened due to serendipity? Serendipity means you are looking for target in formation A, but you got the hydrocarbon in formation B. You were not looking at formation B, but you drilled through it, and by accident you got it. And many of the oil discoveries are happening like that. And after you make the discovery, then you start chasing it all around. How big is the oil pool and stuff like that. So serendipity plays a big, big role in hydrocarbon discoveries. So how much of it was serendipity and how much was it by your predictions from your data? That is very, very important. And the whole game plan of the decision making is very, very nebulous. Now, coming to uncertainty, I took this from a Harvard Business Review. This is a management journal, Harvard Business Review. When you go to an emerging or a frontier basin, when no well has been drilled, nobody knows anything about it, and you even don't know whether a sedimentary basin exists or not in that huge area. There must be some basin, and you don't know anything about it. Nobody knows anything about it. You call it as a frontier basin. And if you are just going to that basin, drilled a couple of wells, and suddenly you find some shows and you think that there could be oil and gas here, it's an emerging basin, then you make a discovery and you are about to go into it, and once you make a success, all other players start making a beeline towards it. And these basins, there's a lot of uncertainty in this, a lot of ambiguity in this. So that is why we call these basins as a basins of uncertainty. But here you cannot make predictions quantitatively. We call it an uncertain basis. So you cannot quantify the uncertainty in these basins. So there is no risk here. That is why I said that there's no risk here. You cannot go to the position of a risk because it's completely uncertain. So in this uncertain area, you can make some qualitative thinking, like you are orienting yourself to a single picture, or whether you can see that there could be 2-3 alternative pictures emerging, which usually happens, or there could be a range of futures happening, that it could be very bad to very good and things like that. So there could be a range of futures, and there could be completely ambiguous. You are just unable to understand what exactly it is at first sight, right? So these are the kind of 4 pictures that emerge, but this is very, very qualitative. You cannot quantify it because you have insufficient information to take a risk or to take a decision about the present condition. Next is the risk matrix. When you are in a basin in early exploration, or you have drilled some wells with step outs and development wells, you're getting successes, or you're in a very mature basin with plenty of oil and gas, there you can do the likelihood of occurrence to the impact of occurrence matrix, which is known as a risk matrix, of impact versus likelihood. And there you can make your risk, you can quantify your risk. You can give numbers to your risk. You can call them qualitatively, you can tell them, and then quantitatively also you can tell them whether this is the kind of risk that you're having. You multiply your impact factor, give values from 1 to 10 or 1 to 5, similarly 1 to 5 or to 10, and then you multiply your impact factors, and then you get your impact values of risk, and then you can quantify them and come up with how much risk you're holding. And then if you have a risk, you can always take preventive measures. You can do further studies to minimize your risk. Oil and gas, although I told you that there are 4 basic tenets of source, reservoir, trap, and sea, there are so many other elements like the timing of migration of hydrocarbons, timing of formation of hydrocarbons, whether there was a leakage, whether the seal was in place when the migration was happening. There are hundreds of other factors are there. So the basic idea of geoscientists is to understand more and more about source reservoir and reduce risk. So you ultimately, there is a risk, but you're reducing the risk by understanding the geoscientific conditions better, and then you're taking the risk. Now, to summarize, we can say the left brain function and the right brain function. The approach to exploration is very structured, right? It's a left brain functions. Over the years, the geoscientists have know that what are the stages to take, what are the steps they have to take, how they go about it. So they from plate to basin scale to prospect, petroleum system, play, and prospect. It's very, very structured. In this fashion they go. It's very, very low. But the interesting facet is within each of these stages, the activity is nebulous. So there is a right brain function involved. Now, technology, the triad of technology, creativity, and science that I showed you. The technology is a left brain function. It defines certain things. Things are very, very organized. You can do your entire exploration work interpretation from start to finish, from exploration to development. There are very sophisticated softwares there, right? And it's completely organized and mechanized. So it's a left brain function, nothing very, very logical. But on the right side is creativity and science, which actually makes you discover petroleum. Now, the creative process, these different stages of preparations, weighing options, these are left brain functions. But the first insight, the incubation, when you are going huddled into a thinking of what exactly the map means, and the illumination or the breakthrough thinking actually happens from the right side. This not only happens in oil and exploration, this happens to all of us. Every person who is here in this room is creative. It happens to all of us in different facets. Now, stages of exploration, certain stages are very, very organized. They are very, very left brain function kind of thing. But the processes, within each stage is very, very nebulous. Now, characteristics of oil finders, academic training qualification is a left brain function, whereas visual thinking skill is a right brain function. The exploration team, the judge, the warrior, and the finisher, they are left brain functions. But the explorer and the artist, they are right brain guys. And management decisions to prospect predictions, they are disguised as logic, but they're actually very nebulous. Whenever you're seeing the top management taking a decision, they'll always disguise this nebulous thing into a logic. They'll try to show it to the chairman that this is very, very logical, but actually it is very, very nebulous. So this is summarizes of what happens of different facets in your exploration. So finally, the creative processes of exploration, the stages of exploration, the quality of oil finders, and the role of the geoscientists are quite structured and generally understood. And it's a left brain function. Okay, it's very, very organized and structured. But what is defined, not defined, is how you go about it within each stage of the process, stage, and team. It is nebulous. This is exactly what I wanted to say. And you can make your own conclusions. I have left it open-ended. And then, this is an urge to you that when you're searching for petroleum, think big. Look at stratigraphic traps. Look at traps. Don't look at small places. Don't look at small structures. wherever you reach the world, look for something big. If you think big, you're going to get big, right? If you think small, you're going to get even smaller. So open your brains to everything. Look at the tectonic setting of the giant discoveries. Avoid the obvious. Look into the frontier basins. Look into the emerging basins. Basin broadening versus basin deepening. Look into the deeper plays which have not been drilled. Do they have big stuff out there? Look at the basement plays. Look at the metamorphic and igneous rocks, their fractures, or whether they are weathered. Look at the granite, fractured and weathered granites at the bottom of the sedimentary basin. There are giant plays, in Southeast Asia, in granites out there, and also in Vietnam, and also in the US, and also in South America. They are there. So look at something different. Look at the unconventionals, the shale gas, the gas hydrates, particularly the production technology, the coal bed methane. Come up with new ideas and thoughts. Brainstorm. These are just words to encourage you to think out of the box. These are words to make you think differently. You should always think differently, not slightly differently, but completely differently. Maybe some may laugh at you today, but tomorrow when you make a huge discovery, you will have the last laugh. And that is my idea behind this talk, so that all of you go and find big stuff out there. On the right side is a diagram. I was just doing some little bit of drawing and painting. I have plenty of time with me. So while drawing, subconsciously geology crept in. I started drawing the anticlines with gas, green is oil, and these are the shelf edges, series of prograding shelf edge, and the point red dots are actually the shelf edge positions, how they are shifting with shifting of the sea level. And this is the basement of the igneous and metamorphic rocks, which is like a tree with branches. So this is the basement, and here I've drawn a meandering channel, and here this is a braided channel. So all these things, whatever come to my mind, and here are the other two eyes. These are the exploration eyes, which are looking into the basin. So this is what I did. Anyway, so finally finishing, I'll end this talk with a famous quote by the Swiss psychiatrist and psychoanalyst Carl Gustav Jung, who founded clinical psychology. And he says, in all chaos, there is a cosmos. In all disorder, there is a secret order. And this is exactly what is seen in the rocks. When you go there, you'll find a disorder or a chaos. And then when you find the pattern of the deposition, you will see the order. Thank you very much. I'm done.
Wow, that was indeed like the most amazing talk I have heard in many years. Like there was a lot to soak in from all your sides, and I think you went pretty fast in that way, I would say, because all your slides need us to look at them and think at least for some time before we can proceed on to the next one. But due to the time limitations, I can understand. But you have given us a lot of things to think on for the next several weeks, I guess. So I think, and this sort of course should be included along with all the petroleum exploration courses that are going around. So in this regard, I have a question for you. How do you think the industry should consider this creative aspect of their employees? Is it given enough importance? Do they take this also into account as a major factor that governs their profit and production?
This is a very important question, Ranjan. And unfortunate part of it is, I believe very few companies actually think in these lines. Few big organizations, and in fact, in one organization as I worked, they looked into my mental aptitude or orientation, whether I was a judge or whether I was a creator or whatever it was, and then they accordingly placed me. But most of the organizations, particularly even government organizations and all that, they don't think in these lines. They treat mechanically 4 people, 1 geochemist, 1 geologist, reservoir engineer. Okay, you 3, you make up a team. They don't look at their aptitude, look at their orientation in thinking. And that is why you don't discover oil and gas, because oil and gas is all about creativity.
Right. Like this.
It is very important.
Yeah. So this
because you need to different people. If all the people think similarly and you are forming a team, you will not find anything, because all of you are conforming to a certain line of thought.
Right.
if you have 4-5 different type of people, they are going to argue with each other. Only then you progress and go ahead.
Yeah, it's like mutation and evolution, right? The more mistakes you make, there's a like certain amount of success also that comes along, right?
Yes, there'll be a lot of failures, but there'll be some success. You know, in every you're a big scientist, you're a postdoc,
Not at all.
you know much more than me.
Not at all.
You know, all the scientific endeavors and experiments, whatever we do, all of them need not be success. Only a fraction of them may be out of the box thinking and maybe a big success. Many of them are they get stuck up.
Yeah, exactly. Like sometimes I often see like we do research, but not all of that qualifies as science. Sometimes we are just doing case studies in the name of science. Sometimes we are just doing something technical in the name of science. But science actually means progress of knowledge. So in what dimension you are adding that knowledge, that matters. Like if you are adding a new dimension to the existing knowledge, then only it's science. Otherwise, like you are just exploring your surroundings and that's all. So yeah. And any advice you have for all of us, like who are still struggling with our careers, and some of us who are also like thinking of getting into this career, any advice? How to unlock our creativity?
Think completely out of the box. Look at unusual things. Think away from the normal. It is not madness. It is actually creativity. Think away from the normal. You may get your answer from some other branch of science with a completely different line of thought. So think out of the box completely. Only then I think you'll be able to hit it off.
Right.
That is very, very important. All of us, we are all very creative people. But at the same time, you respect the principles of the subject. You don't fudge the data. You respect the principles, but you think out of the box. As simple as that.
Thanks. This was really inspiring and like uplifting, quite uplifting, I would say, because most of the times you get drowned in all the details and the technicalities that you lose the big picture, like you said. And we have a couple of like comments from the audience. So I'll just, of course, Sinchan Bhattacharya has pointed it out, but I also want to mention your doodles were just excellent. That's what he exactly wrote. And you are a wonderful cartoonist, we just found out. And we have.
I started drawing after retirement 6 months back. 6
Really?
months back, I started drawing.
You're going to make a great cartoonist if you just carry on. So we have a question from Ahmad Hassan Yasin. So he says,
can I see the questions also on my screen?
Yeah. Just click on the chat that icon for the chat box. It will show up on the right side of your screen.
Yeah, but I'm seeing the.
Do you see the messages?
Okay, I think. No, I'm seeing him there. The more options. This is raised hand, and this is.
Can you see at the lower right corner of your screen? There are 4 icons. One of them is.
Okay. Chat with everyone.
Right. Yeah.
Yeah. In call messages.
Yeah.
Since now I can see. Yeah.
You want me to read it out for you?
Yeah. I can read it. That he's working on mineral exploration, atomic minerals. As a field geologist, we need to submit a proposal to take an area. As a primary field in a situation, put a nebulous idea for the management. How to judge whether the idea of a potential technical tool is a big gamble. Okay, first question, Sinchan, you have 2 questions. First question is.
Sir,
yes.
Sorry to interrupt you. As this is going live in YouTube, I would rather ask Rajendra to read the question for our
please
YouTube
go ahead.
Viewers.
Please go ahead.
Okay, so with that question, I think you have already read it out, so I'll do it from the next one. So, but yeah, please carry on with your answer.
Okay, see, obviously, you're looking at atomic minerals. It's very, very important, at least for our own country. For every country, it is very, very important. And along with the atomic minerals, you get rare earths also. So obviously, you will be looking into the kind of hard rocks which has the genetic milieu where these atomic minerals happen. Also in a sedimentary terrain, in the unconformity also you get atomic minerals like uranium. But you should look for the geological setting. where you can get these kind of minerals, and then look into a setting where you get these minerals but which has not been explored, and then try to go ahead, because that will give you the groundwork from where you'll make your work. You cannot just go blindly into an area and say, no, I'll start looking for atomic minerals here. The basic groundwork of already, if you have found out in a particular geological setting with a particular type of rocks, the environment, that will give you a clue to where you go in some place where you have the same kind of rocks, but where it has not been explored that much. That could be a good clue. That is my answer. Okay, second question, please.
Okay, second question is also, I will put the Sinchan's question first, because like she has two questions. The second is how to put a nebulous proposal to address a problem which could open a new spectrum for mineral exploration.
Yeah, good question, Sinchan. Here, if you are having a illuminating thought that here the atomic minerals could happen, you'll have to relate it with the geology. You'll have to relate it with the kind of setting you have again, and you have to convince them logically. Look, this is the kind of a geological environment or a background where similar things have been found elsewhere. So we are trying to move in and do something. It cannot be a blinder. It cannot be just go and say, I'll work in this part of the country in this kind of rocks and take a reconnaissance call. That reconnaissance can happen. But if you have to find out from known to unknown, from somewhere, if you have some example of known, you try to find out a similar setting, if not similar, somewhat similar, and then suggest so that the management can buy it. You have to give them a story. You have to build up a story. Your proposal later may turn out to be wrong, but initially you'll have to build up a very good scientific story in order to sell your items. That is why besides the work, you should be able to build up the story. That's it.
Okay, thanks. And we have the other question from Emad Yasin. To what extent do you believe that the philosophical framework of petroleum exploration shapes the actions and decisions of industry leaders? How can the exploration of petroleum resources be reconciled with the growing movement towards renewable energy and a transition to a low carbon economy?
Okay, this is this is a big question. The
Yes.
point is, my friend, we are actually moving towards renewables, which is fine. But you see the rate at which the renewables are replacing the non-renewables like your coal and petroleum. Another 30, 35 years, you open up any graph by any top international agency. And for a country like India, it will take another 30, 35 years of using the hydrocarbons before you can actually go into nuclear or renewable energy like solar, wind, or something like electric or whatever. So you just cannot brush off hydrocarbons and coal overnight in terms of vis-a-vis the renewable energy. They will happen side by side. The percentage of renewable energy usage will increase. Currently, it is very, very low, around 10% or something like that, or even less. It will grow. Depends on what rate it will grow. Like your battery technology, they're saying. For battery, you require lithium. Where the Godam is the lithium, man. You can line up a huge factory with millions of cars, but you need the lithium to make up the battery. So you have to go and find out that rare earth somewhere, and then only you can make the battery. So side by side, you need to find out the mineral to form the battery and increase the renewable percentage. Or how fast you can make the solar technology more effective, or the wind technology, which is now going into shallow offshore. You're putting wind farms in shallow offshore around the coast to make it more effective. So how fast you're going to replace the non-renewable energy like coal and petroleum, that is important. And as a prediction, I can tell you that country like ours, like India, for other countries I don't know, we are going to use coal, petroleum 30, 35 years more at least. And we are going to use them in a good percentage. At least 50% or more is going to come from coal and petroleum. You don't know the amount of coal you have in this country. You look at the Geological Survey of India, you see their work and everything. Our coal measurement is only done up to 1,200 meters. But these series of half-graben Permian basins, they have a depth of 2 to 2.5 kilometers. There could be coal below 1,200 meters, right up to 2.5 kilometers. What happens to that coal? How you're going to utilize them? Coal bed methane, shale gas, how do you gas, or you're going to coal gasification? There's so many other ways of thinking about it. So the energy material, renewable and non-renewable energy material is there. And because we are energy deficient, we would require to use it along with the development of the renewables to strike a balance. And then finally, maybe in 30-35 years, the renewables will start leapfrogging.
That was a very long question and a very long answer, but very detailed. Thanks for taking the time for all the answers, Dr. Roy. And I guess there aren't we have still further questions from Karmesh Jha. We all train to follow more process-oriented workflows rather than being creative or design thinking. So it is of paramount importance to learn how to deal with inherent biasness of individuals and data businesses. So
yes,
that's
I agree. Karmesh, no management will tell you to read creativity and things like that, what I'm telling you. But it is very, very important, because ultimately when you're making that breakthrough thinking, you're leapfrogging or taking the science ahead, jumping up, it has to come through your creative thought processes. Nobody tells you that you think creatively, but parallelly along with the processes that you're following, you should look at creativity books. You should try to do different things. You should try to take up a new hobby, do all sorts of creative things. Maybe rustle up a new dish in the kitchen, do anything, do all creative things. Only then you'll be able to provide something which will catapult your answers into something, leapfrog your science into a quantum jump. Otherwise, you'll be making small through the processes. If your processes and methods are extremely defined, you will be only making very small qualitative jumps, very small leaps. But if you are doing creative thinking, one creative thought may leapfrog your whole matter or processes very, very high. So that is why I'm encouraging through this video that you should all look into creative thought processes, read books on creativity, do creative things. All of us are creative. Creativity can be taught, It can be nurtured to make you more conscious about it. You are all creative.
Right. We spend most of our time assuming, but we should rather experiment.
We should question also.
Yes.
Certain principles we should question. Don't question everything, otherwise life will become a question.
Yeah, then it will become hell. So some things you believe with complete certainty, but other things just like question, experiment, and discover. I think we are almost at the end of our session today. So no further questions, or if there are, we can wait a couple of seconds more. But yeah, so please feel free to fill the feedback form that is that was sent to you. And also, if you want certificates, you'll have to send an email to the director and fill out the form. I guess that's right. So Shubham, I think you better take up from here. Thanks, Dr. Roy, and wish everyone a wonderful day.
Thank you, Dr. Roy. Thank you, Dr. Sarkar, to delivering such a nice talk and to managing and hosting this talk. It was a pleasure to hear from you, sir. So thanks again. And I would like to thank all the participants present here. And also, Eid Mubarak to all and happy Earth Day. So see you tomorrow, same time at IIREES webinar. This is the eighth episode of EPS3. We'll have a talk from Mr. Orko Das, Senior Geologist, ONGC. Bye. Till then, good night.
Thank you very much.
Thank
Bye,
you.
everybody.